Hey folks, Robert Quinn here, your LinkedIn semiconductor industry content provider. Today I have Marine Le Bouar on the show with us today. Thank you so much for meeting with us, Marine.
Hi, Robert. Thank you for having me.
Marine is the founder and CEO of Nanotechnology World Association. Marine worked for 20 years in international sales and business development before devoting herself entirely to her true passion, nanotechnology. Over the past 20 years, she has built a solid network of over 170,000 professionals in the industry and is now bringing them together in her resourceful association. She is regularly called upon by governmental agencies or large investment funds across the world to provide them with her unique take and on their pulse on the industry and to provide her vision for the next few years as nanotechnology future unfolds. So, Marine, as the co-founder and CEO of Nanotechnology World Association, can you tell us a little more about the organization as the largest global network entirely dedicated to nanotechnology? I would love to hear your thoughts and what are you working on and what is your current favorite topic in the industry?
Of course. I created the association to promote nanotech solutions across industries. As you mentioned, I spent most of my career in high tech, and I quickly realized that it was extremely complicated to stay up to date with new techs. It's even more complicated with nanos because the term nanotechnology describes such a large field of scientific and technical activities. Basically, everything under zero point 0.1 micron is considered nano. So a lot of advanced materials or advanced electronic devices or molecular biotechnology or chemistry are categorized under the name nanotechnology. So the applications are endless and it touches a lot of many different industries. So we follow the latest developments in nanotech and provide up-to-date information to the relevant industries. We also connect people, researchers, and industrials, investors, and other players in our field. We often get messages from R&D departments looking for potential nanotech solutions for their very specific applications. Basically, they want to know what nanotech solutions are available today to help them improve their products. So given the fact that there are so many different industries that can now benefit from nanotech, it is hard for the market to keep track of everything that's going on. So we do it for them. And since we are mostly interested in the implementation of nanotech solutions, we must separate the nanotech breakthroughs that are super exciting, but not necessarily industry ready, from the processes or products that can already be implemented and manufactured. This is precisely one of the reasons why we have recently created the Nanotechnology World magazine. Each edition focuses on a specific industry, presenting nanotech solutions available for that specific industry. So, as you mentioned, we now have over 170,000 followers and members, and having such a massive network gives us huge visibility. So we help promote our members' technology, products, jobs, etc., via our newsletter, our website, on the magazine, or even sometimes on LinkedIn. And since we sit at the intersections of research, industry, and finance, our role is also to help these different worlds connect efficiently. To answer the second part of your question about my favorite topics, there are so many applications and industry that are directly impacted by nano. It's kind of hard to choose, but I think electronics is my favorite subject since it has a direct impact on our daily lives in so many different ways. Well, maybe maybe I'm biased because I spent most of my career in that field, but I really do enjoy watching the future unfold before my eyes in that industry. We just talked about that before. Um, yeah, I have to mention the significant progress that is being made in medicine, specifically on the diagnosis part, because I think it will change the way we monitor our health in a
Mhm.
very, very near future. I think it will change the way for the remote location, the way people are going to get access to diagnosis, or in countries that do not yet have easy access to point of care. So nanotechnology based application can now enable rapid and sensitive detection of so infinitesimal traces of specific molecular indicator of diseases like cancer, which are totally curable if detected early. So I think that's pretty interesting and pretty exciting too.
I'm very excited about the future of medical technology and the
Mhm.
nanotechnology world and how it's going to affect it. It's going to be very, very, very interesting to watch over the next 30 years because
Indeed.
they're going to have so much. I always look into a lot of the sensors that they're making now and sensors that they're looking to make, and it's just incredible.
Drug
So.
delivery also, there's so many different applications. It's going to be an interesting thing to follow also.
It will. It will. When I read your articles published on your webpage titled Two Dimensional Quantum Freeze or Novel Quantum Entanglement lets researchers spy on atomic nuclei, I have to shake my head and smile because it's always amazing to me that we're actually living in this technological revolution. I have to say, this has to be one of the most pivotal times in history to be a part of the world of nanotechnology. Marie, can you tell me a little bit, speak to the technology shifts we are currently experiencing and explain how the nanotechnology is going to affect our world in the near future?
Wow, this is a big question. um, well, if we just take a step back and look at our planet 4.7 billion year history, as if it were the 24 hours of a single day, recorded history has lasted what for the past tenth of a second, and the industrial revolution for the last 5 thousandths of a second. The technological burst is extremely recent, and look at what we can achieve today. So 3 million years ago we made the first tools. 1 million year ago we started harnessing fire. 20,000 years ago, we began agriculture. 1,000 years ago, we built the first windmills and compasses. And then in the last 500 years, we discovered printing, electricity, telephone, radio, airplanes, televisions, computers, nuclear power, transistors, space flights, internet, smartphones, gene editing, artificial intelligence. I mean, just imagine where we will be in 100 years from now. The growth of technology is exponential, and so is the speed. Nano will have a huge impact in so many different aspects of our lives. Since the first nano article I read approximately 16 years ago, we have gone already such a long way. And I'm still amazed when I read certain news. It's like being in the front seat of a bullet train of innovation rushing towards the future. It's very exciting. Um, Also, as you mentioned, quantum, we are finally able to understand more and more physics at the atomic and subatomic level. It's kind of spooky, as Einstein said, but it's also so amazingly interesting. Speaking of which, the 2022 Nobel Prize in Physics was attributed to Alan Aspect, John Clauser, and Anton Zellinger, who made amazing contribution in understanding quantum entanglement. Advances in quantum will change our fundamental understanding of materials, chemistry, biology, and even astronomy. And these discoveries are extremely valuable resources for innovations. They will give rise to new devices such as lasers, transistors, and they will enable real progress on technologies that not long ago were still considered as purely theoretical, like, for example, quantum computers. So researchers are exploring the potential of quantum science to transform our view on gravity and its connections to space and time. Quantum science may even reveal how everything in the universe is connected, or even multiverse. So we still have a lot to understand at that level, but it's actually what I really look forward, understanding the universe, nothing less. As I mentioned earlier, many advances are occurring in nanomedicine. It includes so many different applications, like, as you mentioned, biosensors, tissue engineering, tissue printing, diagnostic devices, and so many others. I am convinced that it will lead to many more exciting medical breakthroughs within, I don't know, maybe the next 10 years. The energy market will also be, I think, greatly impacted. The way we get it, the way we store it, and the way we transport it. Free, endless, and clean energy is all around us. And with the new engineered material we are creating these days, with all these amazing properties, we will be able to, over the next few years, to, I think, transform the energy industry drastically. Almost every week there is a new breakthrough in, for example, battery technology. It's the speed is amazing. Of course, we have to take a minute to talk about data. We already generate exabytes of data daily. That's millions of terabytes every single day. And this will continue to increase exponentially with the Internet of Things, but also with more and more people being connected simply. So data storage is also a huge area of research in nano. There are so many different labs working on that around the globe. And generally speaking, electronics, which are keeping you and me connected with the world at any time, with endless energy at the touch of a finger, or with embedded technologies within our bodies. And I understand that this could be controversial, because such technology can either be beneficial or a threat, but let's make it clear, all technologies can either be good or bad for humans. It depends who does what with them. Mm-hmm. Artificial intelligence is a little different, though, and I tend to agree with Elon Musk and many others on that one. Maybe we should take a break and think a little bit more.
It's evolving so incredibly fast. It's incredible. Marine, many times we think about nanotechnology as semiconductor chips or medical technology, like what we're talking about. But I so often am reminded that nanotechnology also affects every aspect of our lives, including building materials. And that affects such large-scale things like construction and construction materials. Where do you see the world of material science going in the next 10 to 15 years? And how do you think it'll change our lives and as we move forward with this technology change?
Well, nanotechnology is no longer just a buzzword in the field of material science. It's a reality. Nanotechnology is the ability to build matter atom by atom, and by doing so, designing and building new generation of nanostructure that are way better than existing materials. So by definition, it has an impact on everything we build. The bottleneck is the production capacity. Being able to produce a few hundred kilograms of a specific nanomaterial will allow it only to be implemented in certain products. Also, obviously, there are cost-related issues when it comes to mass production. We may have amazing solutions available, but they also need to be affordable. Um, I have witnessed the birth of so many startups, some of them being well established companies now. I have seen nanomaterials production capabilities explode over the past few years. For example, manufacturing graphene by the ton is something quite new, and it is going to change a lot of things. So yes, nanotech will affect several industries in several ways, and of course, construction is one of them. The applications of nanotechnology in various building products and materials show tremendous progress in that industry. Of course, having access to lighter and stronger materials will modify the way we do things. For example, today we can make windows capable of harvesting sunlight and creating energy or materials that can adapt to the temperature outside, keeping the inside temperature stable, reducing the need for energy, or with the use of nanosilica in concrete, we can enhance its mechanical property, its durability, its elasticity. Another example is Rice University scientists who have optimized the process to convert waste from rubber tires into graphene that can be used to make concrete stronger. So, of course, we still have a long way to go, but in the past few years, nanotechnology have catapulted from being a specialty of a relative handful of physicists and chemists to a global scientific and industrial enterprise. We are growing fast.
It is. It is. It's amazing. So shifting gears a little bit here, I wanted to talk a little bit about R&D and the research and development. So much of the research and development is performed at universities, is developed on 200 millimeter and below equipment, and this equipment is getting harder and harder to get a hold of. Marine, what in the world of nanotechnology, what are other challenges does the industry face in the near future? Whether it's equipment shortages, staffing shortages, what else do you see as far as challenges coming for the world of nanotechnology?
Um, well, the world changed a lot over the last decade, and new challenges have appeared. Over the past few years, we have seen how international supply chains can come under pressure, affecting entire countries' ability to produce, to satisfy demand for energy, microchips, scarce elements, and raw materials. Specifically in our industry, the main challenge is the ability to upscale the production. As I said earlier, nanomanufacturing has been a big bottleneck up till now. It is one thing to create an experiment in a lab to enhance the property of tires with graphene or more resistant paint with titanium dioxide or antibacterial surface with nanosilver. But to be viable in the market, we need to make tons of it and create processes to integrate it into the final products. So to scale up and the scale up and the commercialization is still a big challenge in our industry. While nanotechnologies have shown great promises in the labs, scaling up their production and commercialization can be difficult and expensive. Nanotech research requires expertise in a range of fields, including physics, chemistry, material science, biology, engineering. So, encouraging interdisciplinary collaboration and communication is a must, but it's not easy. Um, Also, there is a need for standards and regulations to ensure the safety and the quality of the nanotechnology products. But developing these standards and the regulations is a long and complex process. And of course, there is also the public perception and education. Nanotechnology is a very complex and usually misunderstood field. And education and engagement are needed to ensure the public support. Addressing these challenges require multi-party approach that involves collaboration between industry, government, academia, and the civil society to ensure the safe and responsible development and use of nanotechnologies. But I am already seeing more and more international projects that involve several labs, involving several specialties, and this is great. Um, we are moving forward rapidly. Sharing knowledge and staff will accelerate tremendously our capability to go further. And as a global association, bringing people together is definitely part of our mission.
Marine, what are your thoughts on the U.S. CHIPS Act and other nations' CHIPS Acts in R&D? Is the capital enough? How much of it will go towards funding nanotechnology R&D?
Well, out of the 52 billion allocated to boost semiconductor manufacturing, slightly more than the 13 billion will be dedicated to research and development, as well as workforce training. Is that enough? Well, it depends on the expectations. Is it enough to dominate the market? Currently, US chip manufacturing plants only account for about 12% of the world's semiconductor manufacturing capacity. 75% of the world's chip manufacturing is now concentrated in East Asia. And let's not forget that it costs 50% more to manufacture chips in the US than it is in Taiwan. So simply having the facilities already set up to produce or expand chip manufacturing gives Asia a big advantage. However, with the right framework in place, America's entrepreneurial drive can be a formidable force, but it needs to move quickly with the right level of autonomy to allow business creativity. Despite the United States' dominance in chip design on a global scale, there is a need to expand this capability to include domestic manufacturing. Also, in the US, there is both a shortage of new graduates and experienced workers with the technical and engineering knowledge necessary to manufacture semiconductors. I I recently read that many of those who might have the right experience instead prefer to work in other trendier industries. And so, even if you were to build 10 new microchip plants, it would be a challenge to staff them. So, money alone cannot solve the problem immediately. It takes time to build the talent and the supply chain to support a powerful homegrown industry. If the question was it enough for the US to be a leader when it comes to cutting edge technology microchip, then probably so, yes. In terms of design expertise, a lot of it still resides in the United States. but there is a high volume of lower end chips that is required for lower end applications, and gaining independence from international supply chains for those is very unlikely, in my opinion. So, to make a long story short, the CHIPS Act is a good start, not enough to dominate the market, not enough to be independent, but definitely enough to be a market leader in the next generation microchips.
Very much agree with you. It's going to be interesting to see the future and see how much more governments around the world invest within that sector. Okay. I would like to thank Move Technologies for sponsoring this Movers and Shakers show as we deep dive into the semiconductor industry with some of the top industry leaders. If you have any used refurbished equipment, or if you would like to buy or sell any equipment, please feel free to reach out to me on LinkedIn or check out my Move webpage or our Move webpage at www.moov.co. Again, thank you again for watching the Movers and Shakers show LinkedIn series. And Marine, thank you so much for joining us today. This has been
My pleasure.
amazing talking to you, and it's been great just being able to hear your thoughts on all this.
My pleasure, Robert. Thank you.
Thank you so much. Have a great day. Bye.
You too. Bye.